So now that we've gotten a handle on what we have to restrict the domain to for each of our six trig functions, and also we understand why we have to restrict the domain in order to create the inverse trig function, now we're ready to sketch some graphs of these functions. So the inverse function of y equals sine x. Anytime, just like we learned back before spring break, when you find the inverse of a function, you just switch x and y. All right, but it is normal to have an equation written in the form of y equals. All right, so when we're talking about the inverse function of sine, right, we don't write it x equals sine y. All right, we solve for y, and so there's two different ways to write this. Inverse sine of x, right, with the little sine inverse here, or we write it as, we write it as arc of x. Right? So I try to force myself to use both notations so that you are familiar with both. They can be used interchangeably. There's no difference between the two. And you might wonder why earlier, like a couple weeks ago, we were using arc sine and arc cosine, and we were doing problems working on a triangle. And so if you recall from a couple weeks ago, if we were working on a triangle and the angles in the triangle, one of the angles was a right angle, so the other two angles had to be acute. So we were only talking about first quadrant angles anyway. All right, so that's why working with those triangles, we were fine working with inverse sine and arc cosine and all of those other functions without having talked about domain restrictions, okay? Because the first quadrant, we're good, there's no problems, all right? But it's getting out of the first quadrant when we start looking at you know, where the function could be negative, right? Then we run into this case where we have to have domain restrictions. So anyway, sine is restricted to this domain that we saw in the last clip. And so the range of sine, so we should know this, that the range of sine and cosine is -1 to +1. Right? Unless we change the amplitude of our function, that's how we change the range. Otherwise, the sine curve, because remember, we're on the unit circle, right? So the biggest value, you know, this is the point 1001, the biggest value for x and y is -1 or +1, right? So that's one way to verify why that's our range. So anyway, when we form the inverse function, then we take the range and domain and we switch them. Okay, so therefore the domain of our inverse sine function is the range of our sine function. All right, and the range of the inverse function is the domain of the original function. So the -π/2 to π/2. All right, so when we go to graph, I wrote down a couple points here that are on our sine curve. Okay, and so when I do my x and y axes, this -1 to 1, this is now my domain, and my range will be -π/2. So now these are on the y-axis to π/2. Okay, so these are points on the sine curve, right? Which means points on the inverse sine curve, I just switch the x and the y, right? So now I have the point -1 π/2. So plot that. So -1, oh, I'm sorry, that should be a negative. -π/2. Switch the point 0, 0, that's a no-brainer. And then let's switch that point so that we get the point 1 π/2. And when you go to connect these, they don't just connect in a straight line. Okay, so when we graph this, I am concave down this way, and then I'm concave up like that, and that connects there. Okay, so here is my graph of inverse sine. All right, so I'm going to go through a very similar process here with inverse cosine. So again, I can either write it as cosine inverse, or I can write arc cosine. And the range of the cosine graph was the same as the range of the sine graph. Okay, we have a different domain restriction though. This time we restrict from 0 to pi. So our domain will be -1 to 1. And the range will be 0 to pi. Okay, so that means when I go to graph, -1 to 1 again. And this is pi over 2. And so that would be pi. So you take a minute, pause the video if you need to, switch your x and y here, and plot. And again, they don't connect in a straight line. Okay, this is concave up, this is concave down. All right, and there's my graph for inverse cosine. And moving on to tangent. Tangent is restricted from -pi/2 to pi/2. And why are these open brackets? And we have to remember that there is a vertical asymptote line. Oh, I butchered the spelling of asymptote. Asymptote line at x equals -pi/2. Every odd multiple of pi/2, tangent has an asymptote line. All right, but we're not worried about the other places. We're only interested in these two vertical asymptote lines at the moment. So what that tells me when I go to switch my x and y is if I have vertical asymptote lines here, those become horizontal asymptote lines when I find the inverse, all right, because x and y switch. So that means I am going to have a horizontal asymptote line at positive pi/2 and -pi/2. All right, and then when I go to graph this, well, remember that the range of tangent was all reals. Oh, actually, I guess it's meant to be put in this blank here. All right, so the range is all reals. Okay, so then what's the domain of inverse tan, right? The range of tan becomes the domain of inverse tan. So that'll be all reals. And now I'm asked for a sketch. So remember, the graph of tan looked like that, right? With asymptote lines at positive pi/2 and -pi/2. If I switch the point 0, 0, it stays 0, 0. Remember, I was at the point pi/4, 1. Right, so if I switch that, it would become 1 pi/4. Okay, and the graph of inverse tan, when I interchange all x and y points, looks like that. And I didn't work the rest of the examples out in this amount of detail. If you look on to the next page, I went through a similar process with the other three with cotangent, which remember, cotangent had vertical asymptote lines at 0 and pi. So the inverse cotangent is going to have horizontal asymptote lines at 0 and pi. Okay? And again, with the inverse cosecant and the inverse secant, you take all the x and y coordinates, you switch them, right? And that's how we end up getting these graphs. So I'm going to be interested in you being able to identify these graphs, all right? Your homework tonight on this is just looking at a whole bunch of graphs and just writing the equation for each one, all right? In the next segment, we'll go on to some of the exercises.